Welcome back to this 5 minutes to learn Redis series. This part will describe some general concepts and challenges in NoSQL: scalability, high availability, consistency, and performances. It is needed to make the next parts easier to understand. Well, about the origins. Relational databases were designed in the 70s, when resources were expensive and it was designed to deduplicate the data by normalizing it and to save resources. Networking was slow, clustering even did not appear in Stanley Kubrick's 2001 Space Odyssey movie. It was designed to be generic and to fit all the use cases at the price of normalization. It was designed with slow development cycles where data schema was not changing too much and it was enforced by the database in the database. SQL was created to query this storage with an excellent flexibility, but joins are costly and need indexes to improve performances. They are not very scalable horizontally by design, making scalability of relational database a real pain. This was not the main goal at this time. These limitations were fine until companies such as Google, Facebook or LinkedIn hit them with their dataset size and their specific needs. Fortunately, they also had the human resources to implement a specific data storage and a query language to fit their need. Let's take an example with a columnar database, when we store customers in a database. If the need is a transactional need, such as an ERP, the smaller needed information is a whole customer record, and storing this customer record as such in a relational database is fine. But if the need is analytical, such as what is the number of children of my French customers, we only need to access two fields of each customer: NB children and country. So a record-oriented storage is not efficient because we need to fetch a whole record to get only two fields from it and repeat this process. On the other hand, a columnar storage is better because the granularity of the storage is the field that we have to scan only two columns. Well, basically, instead of fetching a lot of information from the storage and filtering them afterward, we filter before and fetch only the required information from the storage, which is slow. Of course, it would not be efficient if we had to rebuild customer records. This is not a storage for a generic approach, but a specific storage optimized for a specific need. You might not have the same dataset size for sure, but you might have the same specific use case, and you can leverage these NoSQL databases. Well, regarding the goals and challenges, NoSQL databases were designed from the very beginning to be scalable using horizontal scalability on commodity hardware. But the more hardware we use, the higher failure probabilities are, coming with availability challenges. High availability has to be included in the design to mitigate this higher failure risk in a worldwide system where the weekend night concept doesn't exist. High availability means to duplicate the data. This comes with another challenge, the consistency between copies. The replicated data needs to be consistent with the original data when a failure occurs or when the reads operations are executed from the replica. The replication needs to be synchronous when real strong consistency is needed. Synchronous replication comes with another issue, performances. Read operations can be very fast if the replication of the write operation were synchronous and slow, or read operation can be slow if write operations replication was asynchronous, because the consistency has to be checked at read time. Okay, so we have seen why NoSQL appeared and what are the main challenges. In the next part, we'll dive into the scalability challenge, how it is usually addressed, specifically in Redis and Redis Enterprise. If you found this video useful, you can like and share it. If not, thumb it down. This is also useful for me to tune the content. If you want to learn more, you can subscribe. I wish you a wonderful day.